we have a factorial equation and we have to solve for x in this equation. That is, we have to find the value of x. Okay, in the first step, what I'm going to do is I'm going to get rid of the denominator 3 factorial, 8 factorial. So for that, I have to multiply both sides of this equation by 3 factorial and 8 factorial. So 3 factorial times 8 factorial times x square negative 3x factorial over 3 factorial times 8 factorial. So on the right side, 15 is multiplied by 3 factorial times 8 factorial. Okay, I multiplied both sides of the equation by 3 factorial times 8 factorial. So this one will cancel out. I have x square negative 3x factorial on the left side. On the right side, I have 15 times 3 factorial times 8 factorial. Okay, here on the left side of the equation, we have factorial for single stuff, x square negative 3x. On the right side also, if I have factorial for single stuff, I can compare the stuff on the left side and stuff on the right side, and I can solve for x. So, but here we have factorial for two numbers, and apart from that, there is another number multiplied. So now my aim is to write this expression as a factorial of single stuff. Okay, let me do this. X square negative 3x factorial equals to, so for that, what I'm going to do is I'm going to write this 15 in terms of its prime factors. Then I'll be getting 5 times 3, and I can expand this 3 factorial. Then I'll be getting 3 times 2 times 1. And I keep this 8 factorial as it is. Okay, so we have x square negative 3x factorial on the left side, on the right side. So when I multiply this 2 times 1 is 2. When I multiply 2 by 5, it's 10 times 3 times 3 is 9 times 8 factorial. Okay, so let's evaluate this one. So I'm going to write 10 times 9 times 8 factorial. So 10 times 9 times 8 factorial means what do we have to do? We have to expand. Expand means we have to write the numbers from 8 to 1 in descending order and multiply them all. That is 8 times, 7 times, 6 times. It will keep going up to 1. So 8 factorial is expanded over here. Actually, what do we have over here? We have numbers from 10 to 1 in descending order, and all of them are multiplied. Actually, it is equal to 10 factorial. So the simplification of this expression 10 times 9 times 8 factorial equals to 10 factorial. So I can plug in this 10 factorial for this expression over here. Okay, let me do this. X square negative 3x factorial equals to, for this we can write 10 factorial. Okay, here on the left side we have factorial for single stuff x square negative 3x. On the right side also we have factorial for single stuff 10. So whenever two factorials are equal, so the stuff we have in front of the factorial on the left side, the stuff we have in front of the factor on the right side can be equated. So then I get x square negative 3x equals to 10. Okay, now I'm going to subtract 10 from both sides. Then I'll be getting x square negative 3x negative 10 equals to 0, because it's 10 and negative 10 will cancel out. Now it's a quadratic equation in standard form. The coefficient of x square over here is just 1. Actually, we don't have any number in front of x square, we have to assume it's 1. So to solve this quadratic equation, I think I can use the method factoring. So for that, I have to take the constant term over here. So negative 10, I have to get two factors for this negative 10, such that the product of the two factors equals to negative 10, and the sum must be equal to the coefficient of x, that is negative 3. I think negative 5 positive 2 will work. So when I multiply negative 5 and positive 2, that is equal to negative 10. When I add them, negative 5 and positive 2, that is equal to negative 3. So the two values of x are, you just have to change the signs of the two factors to get the values of x. So the first value of x is positive 5, the second value of x is negative 2. I just changed the signs of these two factors to get the values of x. Okay, I solved the given equation and I got two values for x, 5 and negative 2. Okay, in the next section, what we can do is we can verify. So these two solutions, 5 and negative 2. So that is, we have to check whether these two values of x, 5 and negative 2 satisfy the given equation or not. Okay, let's verify it. Okay, we got two values for x, 5 and negative 2. Now what I'm going to do is I'm going to verify the first solution 5. So that is, I'm going to plug in x is equal to 5 into the equation and check whether this equation is satisfied by the value 5 of x. Okay, so let's plug in 5 for x. Then I'll be getting 5 square negative 3 times 5 factorial over 3 factorial times 8 factorial equals to 15. Okay, let's simplify this. So 5 square is 25, negative 3 times 5 is 15 factorial over 3 factorial times 8 factorial equals to 15. So 25 negative 15 is 10 factorial over 3 factorial times 8 factorial equals to 15. Okay, now I'm going to expand this 10 factorial. So when I expand this 10 factorial, I have to write the numbers from 10 to 1 and multiply them all. But I don't expand this 10 factor up to 1. I stop at the middle, specifically at the number 8 and factorial. So whenever I expand a factorial, and if I want to stop it anywhere in the middle, I have to put factorial over there. So here 10 factorial equals to 10 times 9 times 8. It will keep going up to 1. But I stop at the middle, particularly at 8. So I have to take factorial over there. Over 3 factorial times 8 factorial equals to 15. So here you have a question. Why should I stop the expansion of this 10 factorial, particularly 8? Because we have 8 factorial in denominator. So if I stop at 8, I have to put factor over there. So 8 factor can be cancelled. And we have 10 times 9 over this 3 factorial can be expanded as 3 times 2 times 1, which is equal to 15. Then we get 3 goes into 3 1 times, 3 goes into 9 thrice, 2 goes into 2 1 times, 2 goes into 10 5 times. So 5 times 3 is 15. 15 equals to 15. It's 2. So the equation is satisfied by the first solution 5. Okay, now we can verify the second solution negative 2. Okay, I'm going to plug in x is equal to negative 2 into the equation. Then I'll be getting negative 2 the whole square, negative 3 times negative 2 factorial over 3 factorial times 8 factorial equals to 15. Okay, so the evaluation of negative 2 whole square is just 4, and negative times negative will become positive. 3 times 2 is 6 factorial over 3 factorial times 8 factorial equals to 15. So 4 positive 6 is 10, and then we get 10 factorial in numerator, and in denominator we have 3 factorial times 8 factorial is equal to 15. Already we have evaluated this expression 10 factorial over 3 factorial times 8 factorial when I was verifying the solution 5. So what is its evaluation? So its evaluation is 15. So 15 equals to 15. So this is true. So the equation is satisfied by the second solution also. So both the solutions are accepted, 5 and negative 2 for x.